Okay, this is an example from an activity in class. We didn't go through the example in class, so I'm going to go over it in this short video. So this is the problem with a pressure cooker, which is basically a pot that you put on a stove with an increase of heat. These are flames. The nice sound effects. The liquid inside the pot starts to vaporize, turns to steam, and it produces pressure. So pressure builds up inside the pot, and this little thing on the top called a petcock that lets the pressure out of the pot. And the weight of that essentially keeps the pot sealed, and then when the pressure inside the pot reaches a certain level, it will push that little petcock up and release the pressure so that the whole pot doesn't explode. And the goal in this problem is to find the mass of the petcock if the internal pressure is 100 kPa and given a cross-sectional area of 4 millimeters squared. If we focus in on the goal, which is to find the mass of the petcock, look at the pressures inside the pot, and if we're looking at mass and pressures, that looks like or sounds like forces, which leads me to a free body diagram. So since I've taken statics, I'm pretty comfortable drawing a free body diagram, and that's a good place to start. Really zero in on the petcock, which is this triangular piece right on the top, and the pressure that builds up inside is going to push up through the lid and then basically push up on the petcock. Solving the free body diagram of the petcock is definitely going to get me mass of the petcock and the pressure, which is one value that I need to know. And the pressure inside, now that I've isolated just the triangle piece, acts on the inside of my petcock, and I'm going to draw that as a distributed load, and I'll write the pressure times area right over here, because in my free body diagram I only want to have forces. Now, given that I have identified all the forces acting on my petcock, it is not accelerating, therefore the sum of the forces in the y direction are going to be equal to 0, which means I'm going to have the pressure times the area acting upward, positive y, and counteracting the mass down. Now I've got an equation with m in it, the mass of the petcock, and now I can solve for PA over G. The internal pressure is going to be 100 kPa times 4 millimeters squared divided by 9.8 meters per second squared, which is going to equal, and that equals 40.82, and that looks like kPa millimeters squared over meters second squared. So I got to figure out what all my units are. In review, the units were checked at the end and carried throughout the calculations. And the solution of grams is consistent with the goal of trying to find the mass of the petcock. And just as a comparison, 40 grams is about less than 1/10 of a pound, so this certainly seems to be within the range of what would be expected. So, thanks for listening.